P, -1, -4 is a terminal point of an angle theta in standard position. So we've learned standard position already. We have an angle starts on the positive x-axis and goes to its terminal arm. So the fact that they tell us that -1, -4 is a terminal point, that means that it's on the terminal arm. Determine the exact values of the 6 trig ratios. Found it. Yes. Sine, cosine, tan, and cosecant, secant, and cotangent. So we start on this question by drawing out what do we know. We know there's an angle. We know that the point, oh, I don't even know if that point is. I'll draw it. 1 this way, 1, 2, 3, 4. There we go. We've got -1, -4 as a point, and that point is on the terminal arm of an angle theta. And we want to find trig ratios. What does trigonometry normally make you think of? Triangles. So we're going to need a triangle in this question to help us solve for trigonometry. What kind of triangle do we use for sine, cosine, tan? Right angle triangles. Now, all of our definitions are going to come into play here. We're going to make a triangle, and the triangle that we're going to make has to go back to the x-axis because it's important that we include our reference angle. So our reference angle was always the angle going back to the x-axis. So the triangle that we're going to make needs to go back to the x-axis as well. How long is this side of the triangle? 1. How long is this side of the triangle? 4. How long is this side of the triangle? Square root 17. You are going to get really good at doing a squared plus b squared equals c squared in your head. Is everybody okay with square root of 17? 4 squared is 16, plus 1 squared makes 17, equals square root of 17 for this side. Yes?
Is the radius of the circle 1?
In this one, the radius of the unit circle is 1, but on this one, this length is root 17. If I drew a unit circle on here, that's how big it would be. 1 unit, because its radius would be 1. But this one, the triangle that we've drawn, isn't on the unit circle. -1, 4 isn't on the unit circle because it's too far down. Okay? But it's good to have that picture of where is the unit circle compared to this. Now, we want to find sine of theta, cos of theta, tan of theta. On a triangle, what's sine of theta? Opposite over hypotenuse, right? So we take our reference angle and say, on this triangle, the opposite over hypotenuse would be 4 over root 17. That's what it would be for my reference angle. But because my actual angle is in quadrant 3, according to my cast rule, it's going to be negative. So our reference angle finds us the ratio, and then we have to think back to our cast rule to figure out if it's going to be positive or negative. In grade 11, what did you do if you had a square root on the bottom? You multiplied by the square root. What was this called? Remember that? Simplifying that to write it that way. What was that called? Something to something? Oh, I remembered the. No. Rationalizing the denominator. Does that sound familiar? No? Didn't pay attention at all during that part? Okay, that's fine. Because you made the denominator a rational number. Okay? Now I'm going to tell you in the grade 12 course, they assume that you know how to do that. They assume it so much that you don't have to do it. you can leave your answer as negative 4 over root 17. If it was multiple choice, chances are the multiple choice answer would have it rationalized. So you still need to know how to do it. But you can leave it as negative 4 over root 17 and not lose a half mark for not simplifying. Isn't that nice? Okay. Cos of theta. Oh, do you want to know what else they let you do in grade 12? If you get your final answer to be 9 over 12 as a fraction, what did you have to do in grade 11? Reduce it to 3 over 4, right? In grade 12, they assume you know how to reduce things. And so, they don't deduct you if you don't reduce. Isn't that nice? And if you make a mistake while reducing, they still deduct marks. But if you don't reduce, then you get full marks. Okay? Again, on multiple choice questions, they wouldn't keep their answer as 9 out of 12. They would have it reduced, so you still need to know how to do it. Now, cos of theta. Well, cos is adjacent over hypotenuse. I look at my triangle, I look at my reference angle. The adjacent is 1, my hypotenuse is root 17. It's in quadrant 3, so it'll be negative. And we've got cos of theta. Okay? Careful here. At this point, I do want you to reread the question, because do you understand when you read this question that it wants you to find sine of theta, not theta? It's a common mistake that kids find. They're like, I need to find theta. This isn't asking you to find theta. It's asking you for the trig ratio of theta. It's asking you for sine theta. Don't have to solve for theta. It's asking for cos of theta. Next, we have to find tan of theta. And tan of theta would be opposite over adjacent. 4 over 1, you wouldn't have to write the over 1. And it's in quadrant 3. Does it make sense that tan would stay positive? So those are our primary trig ratios. We also need to figure out our reciprocals. So reciprocal of sine is cosecant, and reciprocal means that we flip the fraction. And so if sine of theta is negative 4 over root 17, does it make sense that cosecant is root 17 over negative 4? And it doesn't matter where we put the negative. You could keep the negative on top, you could put a negative in front, or have that negative in the bottom of the fraction. The reciprocal of cos is secant. So secant would be negative root 17. You could write over 1, but you wouldn't need to. And finally, reciprocal of tangent is cotangent. That'll be 1